Howdy y'all, it's the Diabolic VTutor. And today we're going to be covering the trig function still. Unfortunately, it's still trig o'clock. We're focusing on the expansion rules, the sum and difference formulas for trig. And last time I left off, I was supposed to do the problems with the algebra inside it, but I didn't get to it. So now we're going to do it today. And then we'll probably finish up with a little bit of review. A bunch of random review problems. So let us start off with the first one. We have sine of the 3 pi. So make note that there's a variable right there. We have sine, and then we have sine. Already this is indicative of what kind of condensation. That's going to be pi over 24. And then minus cosine cosine. So cosine of 3 pi x. Make note that those arguments are the same thing, of course. And then cosine of pi over 24. Again, this one is the same as that one. And all that is equal to square root of 3 over 2. So that's the problem we're looking at. So what exactly are we doing? Well, this is kind of a review, but now it just incorporates a little bit of algebra. So again, we have the trig functions together. It's the sine functions of the same type that are together, and then these are the cosine trig functions that are together. So we know this is going to condensate into the cosine function. So if you recall, if we have sine of alpha plus beta, then that one expands into sine, cosine, cosine, sine. And then sine keeps the same sign, so if it's plus in there, then it's going to be plus for the expansion. And then we have cosine, sine. So that's going the sine expansion, and if we have the cosine expansion, let's say we have cosine of alpha plus beta, then we keep the trig functions together, so it would be cosine, cosine, flipping the sign, and then sine, sine. So that's the expansion for this one. So we are not looking at this one for this particular problem. We're looking at the cosine one. And again, we can see that the sine types are together, and then the cosine types are together, and then there's a subtraction between those two. So we know we're dealing with this one in particular. But make note that the cosines are the second term next to the minus, rather than the sine ones. So be aware of that. So this one we should probably do a little bit of rearrangement, which is what we're going to do. I highly encourage that. We can divide negative from both sides, but I'm just going to simply factor it out. You know what? Yeah, let's multiply both sides by negative. So again, this is what we're dealing with ultimately. Make reference of that one. I'm going to put it down here. And then the opening move that I would probably suggest is to multiply both sides of the equation by -1. So distribute it to this term, and then to that term. So thereby getting, this one turns, the sign flips, thereby getting a positive, so it becomes positive cosine of 3 pi x over 8. Close parenthetical, and then that one cosine of pi over 8, pi over 24. And then again, negative to this one, we flip the sign from positive to negative, thereby getting minus 3 pi x over 8, and then times sine of pi over 24. And of course, make sure to distribute the negative to the right-hand side. And this one should be a very familiar ratio. It's like one of those 30, 60, 90s. So everything looks pretty good at this point. This one now matches pretty well with that one, so we could just simply condensate it. So let us get number 1. Again, these cosines are together and the sines are together, so therefore this must be a cosine condensation for this one. That's argument number 1 plus argument number 2. Let me color code that real quick. So this is red. We call that red, and that's red. And the second term is the blue one. So blue, the second argument is the blue one. And we're transitioning from the negative right here back to the positive. So it's going to be plus between the two arguments. So let us do that. So in the parenthetical, argument number 1, from left to right, following standard Western style reading, and then plus the second argument, because again, negative, we are flipping to positive, as per the algorithm. So pi over 24. Alright, close parenthetical is equal to, copy paste the negative root 3 over 2 ratio. Okay, so we don't need this thing anymore. It's gone. Until the next problem, maybe. Alright, so we do have this situation right here where we have two terms and then they are combinable. This is going to be denominator 8. This is denominator 24. So just multiply top and bottom by 3 to get to same denominator. So we're going to get 3 pi x over 24 plus pi over 24. That is equal to, copy paste that please. Okay, looking okay so far. And of course this is combinable. Honestly, I just would have skipped and put it like this. Well, this is actually kind of awkward. Okay, so this one is just pi, and this is 9 pi times x, so it's a little weird, but that's okay. I forgot to put the 24, whoops, 24. Alright, so just summate the top part, we're going to get pi, 9 pi x plus pi, all over 24. Again, not the nicest looking thing, but that's okay. With this nonsense. But that's familiar nonsense. So what exactly are we dealing with in that particular situation? Well, if we sketch out the quadrants and then try to figure out where the reference angles are hanging out. Don't put the negative on the hypotenuse, so it's going to be negative adjacent. So we have two situations, potentially. We have a negative root 3, or the adjacent, and then it could be going upwards like so. So that's a 2 to positive 1, or we can have the reference triangle in the third quadrant with a negative 1 opposite. But still negative root 3 for the adjacent. So it could be in either of those two particular quadrants for the reference angle. We have no domain restrictions, so unfortunately we're going to end up with the infinite answer scenario. So that's going to be wonderful. So let us proceed forward. So again, we have this thing right here. So we have two scenarios for this one. Again, it could be this particular angle, which is from here to there. What is that? This is the slim angle that opens up to the slim side, so that's going to be over root 6. So, but it's short of half circle, so it's 5 pi over 6. And then as for the other scenario, for the smallest possible positive reference angle, is from here to there. That one is 1 pi over 6 past halfways for a full circle. So it's going to be pi, which is 6 over 6 pi plus pi over 6. So that's 7 pi over 6 for the reference angle again. All right. So this inside part, we will force it to be that one, and then this one we will force it to be that one for the two scenarios. So let us do the darker purple first. So copy pasting inside part, so we have 9 pi x plus pi all over 24, and that should be equal to this particular reference triangle, which is again 5 pi over 6. And this is just one answer. We want to capture all the answers, all the coterminal angles. So anything special to get to the next one? Nope, it's just going to be an addition of one full rotation, which is just plus 2 pi. So plus 2 pi. And every iteration of 2 pi. So k is going to be the letter I'm going to use for that one. So k is an integer. So if you want to be fancy smancy, you could say k is an element of all integers, if you care for notations. I think some people prefer to use n. I think some people use 2 pi n, and then instead of k, they just use n. But I don't think it matters. That may or may not be standard. I don't know. I don't remember. But that's the setup for this particular situation. You could be fancy by saying this one, or you could just say k is an integer. This is more formal, of course. This just means integer. Alright, we need to solve for x. X is buried right there, so we need to get rid of the superfluous stuff hanging around. And then the easiest move that I can detect is to multiply both sides by 24. 24 over 1. So distribute through the first term, second term, and then third term. Let's see how it ends up. So 24 cancels with the 24 for the first term. And then the 24 partially cancels with the 6th, leaving us with a 4 times a 5 up above. So that's going to be 20 pi. And then lastly, this one times this one gives us a kind of an absurd 48. I don't think we need to do that, though. Yeah, that's okay. We'll talk about this afterwards. And then, of course, we still have this nonsense right here, and that one right there. This one has a k, so I'm not going to combine those two just right off. So let us solve for the x by subtracting the x from the pi from both sides, and then we'll divide both sides by 9 pi. So here we go. So that looks kind of funny. And then we're going to multiply both sides by 1 over 9 pi. Just to clear the coefficient in front. Thereby getting x fully isolated, and then distribute, and then distribute. And since both of these are going to be divided by 9 pi, I'm just going to combine them together like so. Okay, not looking the best, but let's clear the pi from each of those terms. So we have 19 plus 48k all over 9. And that one should be good. That's going to be the first answer for the first scenario. Again, that's the darker purple situation. All the answers that are encapsulating this one are captured right here. Again, k is an element of all integers. Answer number 1. And of course we have the second scenario to deal with. It's the lighter purple situation in quadrant 3. And that one is going to be the 7 pi over the 6. So we're going to take this argument right here. What could possibly give us this ratio? It's going to be that reference triangle and all the coterminal ones to 7 pi over 6. So take the argument. 9 pi x plus pi all over 24. And that's going to be equal to 7 pi over 6. This is just one answer. We need to capture all the coterminal angles since there are no domain restrictions. So plus the usual 2 pi k. K is an element of all integers, so integer. And same strategy, we're going to multiply both sides by 24 to clear the fraction, and then we're going to divide both sides by oh no, let's do that after, one step at a time. So we're just going to multiply both sides by 24 to clear the fraction from the left hand side, to slowly isolate the x, and then a partial cancellation. And that's going to be the same old 48 pi k. Subtracting the x from both sides, I'm sorry, not the x, the pi from both sides, to isolate this term. So thereby this one becomes 27 pi. And finally, we're just going to divide both sides by 9, or multiply both sides by 1 over 9 pi to fully isolate the x. thereby getting x is equal to 2, and then this one. I'm gonna keep these two together, so I'm just going to have both of these terms in the numerator divided by 9 over pi. And of course, we can do some simplification. Wait, what am I doing? I flipped it. Whoops, this is on the numerator. All over 9 pi. And of course, this is partially divisible by 9, actually fully, but we want to keep this, I want to keep this as one fraction. So this one's divisible by 3, but not 9, but then this one is divisible by 3. So let us cancel 3 pi from the top and bottom. So divide by 3 pi. And divide by 3 pi. Equal to 16, okay. Divide by 9 pi is just 1. So we get a pretty, oh, I'm sorry, divide by 3, whoops. So this is going to be 3 in the bottom. So a pretty clean answer. There it is. Again, k is in the element of integers. And I think that about concludes it for this first one. Again, we have two answers, so let us consolidate those two together. So answer number 1, and then answer number 2. We'll take those two and just put them next to the question, which is right here. Alright, so there it is. Again, this is just a condensation problem where there is an unknown in one of the arguments. But we do have a very clean fraction right here. It's not like a something plus something else. It's just strictly one fraction, which makes these type of problems a lot nicer. But, you know, just follow standard procedures. Follow the algorithm. Just recognize what type of condensation this ends up being. There is a subtraction between these two. It's the sines are together with the cosines, so we know it's going to be a cosine condensation. So we also make note that the signs will flip. And then once we get to this situation, we get to a fairly standard situation. This one is just essentially a problem that's kind of similar to this one. Cosine of x is equal to negative root 3 over 2. And we've done plenty of these problems before. It's just that now we just have a little bit more complicated of a argument. But the steps are ultimately the same thing. Just do your sketches for the reference triangles. Make note of the domain. We have no domain restrictions. So infinite answers for scenario number 1 and then scenario number 2. And then just do the algebraic manipulations. Alright. So that's it for the first one. Let me cross it out so I never do this problem again. Ever again. And then we're moving on, of course. So problem number 2. We have sine of pi x over 5. Close the parenthetical, and then cosine. Make note that these are different types of trig functions together. It's the sine one next to the cosine one. So have a sneaking suspicion of which condensation this is going to be. And then we have x plus 2 in parentheses pi, all over 15. Close the parenthetical, and then it's going to be plus cosine sine. Always do the quick evaluations, and then this is going to be equal to root 3 over 2, our familiar friend. We're pretty used to this ratio at this point, right? Okay, so trig functions, we have the sine one with the cosine, so we know this is going to condense into the sine function because it's sine, cosine, cosine, sine. And then this argument here matches with that one, and this argument here matches with that one, so we know it condensates into the sine. There's a plus in between, so we know we're going to sum the two arguments together. This is argument number 1, and then that is argument number 2. and it's just going to be the sum of those two. So we're going to have pi x over 5. Sign, you keep the same sign. So we know it's plus, and then copy paste this one. Close the parenthetical, copy paste the right hand side. Alright, there we go. Again, no domain restrictions, so we do have infinite answers to report. That's always fun. And this one, they're nicely combinable. This is just denominator 5, this is denominator 15. So top and bottom times 3 to that one. So we're going to get 3 pi over x. I'm sorry, 3 pi times x over 15. So again, since this one's already 15, I'm just going to shortcut it a little bit by putting the plus and that thing right there. So I should probably distribute this since this one has an x. Yeah, let's distribute the pi to each of those terms. So we're going to have pi x and then 2 pi. So that's the entirety of the argument for the sine function. Still copy pasting the right hand side. There we go. And then we make note of the sketching. Let's do the sketch. We're probably going to end up with 2 scenarios, so let us jump straight to the coloration. So scenario number 1, we have positive root 3 over 2, so that could be in quadrant 1. The opposite is positive root 3, hypotenuse is 2, and adjacent is positive 1. And then of course we have the other scenario that's in this particular quadrant, number 2. Because there we can have a positive opposite root 3 as well. Just trying to make things a little bit more to scale. There's a negative 1 adjacent. Alright, so that particular angle, that's the wide angle that opens up to the wide side, so that's going to be over 3, but it's short of half a circle, so it's going to be 2 pi over 3 for the reference angle. And then for the first reference angle, the darker purple right there, that's the standard pi over 3, because again, wide angle to the wide side. Alright, so we have the 2 scenarios set up, and all we need to do is set up the algebraic relationships for situation number 1 and then situation number 2. So this is kind of a mess, so I'm just going to go ahead and combine these two. So that's going to be 4 pi x plus 2 pi all over 15. So that's the argument, and then we want to equate that to pi over 3 because that's going to give us this particular ratio. But again, this setup is only one answer. We need to capture all the coterminal angles with this one. So plus 2 pi k, standard situation. K is an element of all the integers. This is going to feel very familiar. We're just going to do this thing as we did to the previous problem. We're going to multiply both sides by 15 to clear the denominator to isolate x, thereby getting 4 pi x plus 2 pi is equal to distribute. Wonderful. And then we're going to subtract the 2 pi from both sides and then divide by pi 4 afterwards. So subtract this one first. We'll have some semblance of order. So these two are like terms. And then for the final cleanup, for the final isolation step, we're going to multiply both sides by 1 over 4 pi to clear this thing. I'm going to put those two terms together. All over 4 pi. And then we just go to canceling the pi's, thereby getting the 3 plus 30k all over 4. Again, k is an element of integers or something like that. So this is going to be the answer for the first scenario. And then we move on to the second scenario. So that just takes care of the reference triangle in quadrant 1, and then now we need to get the reference triangle for quadrant 2, which is again 2 pi over 3. So take the old argument. I'm going to copy paste this one since that one's already combined. Let's see if we could skip some steps just to expedite the process. So we want 2 pi over 3 for the reference, and then of course get all the answers, so plus 2 pi k, where k is an element of all integers. And then we're going to multiply both sides by 15 over 1. And I'm just going to go ahead and shortcut this and then subtract the 2 pi from both sides. So I'm going to skip a little bit of steps just to save some space. So this one is cleared of the 15, and then this one's going to be cleared partially. 15 divided by 3 is 5. 5 times 2 is 10 pi. 10 pi minus 2 pi is 8 pi. So that's the skip I step. That's the step I skipped, not the skip I stepped. That sounds weird. And then this one is divided by or times 15. So that's going to give us 30 pi k. And then divide both sides by pi over 4. Pi over 4, I mean 4 pi. 1 over, multiply both sides by 1 over 4 pi. I'm really misspeaking. So this one partially cancels to give us 2. And let's keep it all under one fraction. So a 4 does not go perfectly into the 30, so I'm not going to perfectly divide this by 4 pi. So I'm just going to divide this one by 2, divide by 2 pi, and then divide by 2 pi. So this one divided by 2 pi is 4. This one divided by 2 pi is 15k, and then this one divided by 2 pi is just 2. So I'm going to keep the answer like that. And that should be good. So 2 answers. We have the scenario for quadrant 1, and then we have this scenario for quadrant 2. This is a fancy E. I think it's epsilon. No. It just means element. It just means that k is a number that belongs in the element, is an element or one of the options you can choose from the whole set of integers. So that's like fancy smancy math notation. As you get higher up into the maths, or you get into different branches of math, you just have a lot of funky notations. So it's like strictly learning new languages. Alright, but we're good to go for this one. Oh, this is bad. The cutoff. Whoops. Alright, so we have answer number 1, and then we have answer number 2. Infinite answers, so make sure you keep the k's because we have no domain restrictions. But that's it for the second problem. Crossing that one out, let me take a quick swig of tea. Alright, we're moving on to the third problem. I can't even see it because it's getting blocked. Hold on for a moment. Okay, here it is. We have the 2 times, so this is a little different right there. 2 times the sine of quantity x minus 4. And that's all over 5 with the pi on the side like that. And then we have cosine. Already have sneaking suspicions of what this one is. Cosine of what? Quantity x plus 6 pi. And that's all over 20. So plus 2. Also make note there's a 2 here and then there's a 2 there. So 2 times cosine, and you bet it's just going to be an alternation of these two. So x minus 4 pi again. all over 5, and then sine of second argument. Well, that's ugly, hold on. Okay, that is equal to the square root of 2. So have some hypotheses as you're working through this, sneaking suspicions, recognize certain forms. We have the sine with the cosine, and cosine sine. So this follows the sine, cosine, cosine, sine situation. So we know this is going to condensate. If it does condensate, we know it's going to condensate into the sine function with a plus between the two arguments. And then this argument here matches that argument, so that's good. And this argument here matches that argument, which is also good. But we do have this very awkward 2 in front of both terms, so we're just going to open up by multiplying both sides by 1/2 to clear that awkward coefficient. So should I just copy paste this? Yeah, let's just copy paste. I'm going to cheat just a little bit just to save a little bit of time. So distributing the 2, we're going to clear the coefficient in the front for the sine. So we're going to clear that one, and then of course the distribution to the second term will allow us to cancel out the coefficient as well. Okay, I kind of destroyed the c right there. Whoops. Now it's whole again. Perfect. And of course, distribute the 1/2 to the right hand side. Don't ever forget that. There it is. Alright. So all we did was we just multiplied both sides by 1/2 to clear the awkward coefficient, and then also to make the right hand number into a more recognizable scenario. It's the classic 1 over root 2, so we know this is going to be related to one of those 45, 45, 90 right triangles. So let's carry out the operations with the condensation. Again, we know that this is sine, cosine, cosine, sine. We recognize it as the sine condensation. And then we see argument number 1, and then argument number 2. So this is a quote-unquote a nice situation. Alright, so argument number 1, x minus 4 pi. All over 5, and then sine condensation, you keep the same sign, so it's going to be plus. Copy paste the second argument. And all that is going to give us a ratio of root 2 over 2, which again, I always like to simplify this, or not simplify, I always like to make it, what do you call this? What's the opposite of rationalization? Irrationalization? I don't know. But getting to the more familiar ratios that I am more accustomed to, 1 over root 2. Alright, so that's going to be 45, 45, 90. We're dealing with the sine function, so opposite is positive. So our two scenarios, we have 1, 45, 45, 90 in quadrant 1. Again, the ratio is 1 to root 2. And that's the standard pi over 4 situation. Or the reference angle. And the other one we're dealing with, still positive opposite, so that could be in quadrant 2. Positive opposite, but now the adjacent is negative. And that's just from here to there, so that's another standard angle, 3 pi over 4. And can we make something nicer of this nasty argument? Probably. Since this one is a coefficient for x, and then this one is also a coefficient of x, we could just simply add coefficient number 1 to coefficient number 2, thereby getting 2x plus 2. Oh, and I can do that. Whoops. Before we do that, denominators are mismatched, so top and bottom times 4. Distribute. Yep. So that's going to give us 4x minus 16. And then the right hand term is going to be copy paste. All right. And like I said before, since this is a parenthetical of pi, we just add parenthetical to parenthetical. So we're going to get 5x minus 10 close parentheses times pi. If you think about it, this one is just similar to like 3x plus 2x. So if you have something like this, you could just add the coefficients. But instead of having x, you just have a pi. Okay, so that's going to be the argument for the sine function. Copy paste. So what are we doing at this point? We have two scenarios again. So for quadrant number 1, we're just going to have the reference angle pi over 4. So let's take the argument and set it equal to pi over 4. No domain restrictions, so we have to put all the answers, so plus 2 pi k. K is in the element of integers. All right. Algebraic manipulations, let's get to it. So let's just multiply both sides by 20. Want to cancel out that pi, so 20 over pi to both sides. So this one will cancel with this, and this one cancel with this, freeing the 5x minus 10. And distributive property, pi's cancel, 20 divided by 4 is 5. And then lastly, pi's cancel, 2 times 20 is 40. 40k for all you Warhammer people. Alright. So plus 10 plus 10. And then divide by 5 from both sides. So we're going to get x is equal to, again, plus 10 to both sides. So that's 15. 15 divided by 5 is 3. And then divide this one by 5 as well. So it's plus 8k. No longer 40k. Sorry. Short-lived 40k reference. So what are you looking at? Is this looking good? Yeah, that looks about right. And that's it for the quadrant 1 scenario. Let us jump to the quadrant 2 scenario. So we're going to take that argument, and then we're going to force the argument to be equal to the reference angle, which is 3 pi over 4. So we have 5x minus 10, parenthetical pi over 20. And we're going to be forced to equal to the reference triangle in quadrant 2, which is 3 pi over 4. Same reasoning as before. We want to capture all the answers, so please put 2 pi k. Sloppy. Technically not very strict, but that's okay. I'm not a real mathematician anyway. So we're going to multiply both sides by same opening move, 20 over pi. That is equal to what? 5 times 3 is 15. Then distribute it to the last term. 40k yet again. Plus 10, and then divide by 5 from both sides. So we're going to x is equal to, plus 10 is 25. 25 divided by 5 is 5. And 40 divided by 5 is 8. And that's it. Of course, we should put k as an integer. I'm just kind of mixing up what I'm saying. I'm being a little inconsistent, but that's okay. This is technically cleaner and more official, I guess. So that's answer number 1, and then we have answer number 2. We'll just consolidate those. So there they are. Those are the answers for this scenario. You know what, let me copy paste. No, I feel that's unnecessary. Okay. So I'm just going to zoom on this real quick. So these two are the answers, and then this is the question. And I think we're good to go for this third problem. So let's move. Moving on to problem 4. Guess what's it going to be? Just take a guess, right? What do you think this next problem is going to be about? It's tangent. Yep. But here's the funny part. It looks weird. Check it out. So we have tangent. X plus 2 inside the parenthetical, and then times pi. And then it's going to be plus, very awkward, x minus 2 pi over 28. And it's going to be equal to almost done, I promise. Minus 1. Alright, there we go. So that's the entirety of the problem. Make note, there are no domain restrictions, and we do have kind of an awkward situation. We have a sum of tangents, and then we have a product of tangents, and we have a minus 1 at the end. So I hope you recognize the situation. Honestly, it's only tangent. Oh, I should have made this a little more annoying. Oh, that's okay. Just as a side note, if I had wanted to make this a little bit more difficult to recognize, I would have multiplied both sides by cosine argument number 1 and then cosine of argument number 2, and that's going to make things a lot nastier in terms of the initial impression, but that's okay. There's no need. So this is our problem. Again, we have tangents, so we so we can surmise that this is going to be a sort of a tangent condensation, but again, it looks kind of weird because we have something on the right hand side and then something on the left hand side, but ultimately, if you remember the tangent sum and difference formula, it's going to be something like this. So if you have tangent of alpha plus beta, right, if we have this sort of situation, then the property is this one. We're going to have tangent of the first one plus tangent of the second one. So keep the same sign on top because sine is on top. And that's all over. And then we're going to have the 1 minus. So that's the property, that's the identity that we're supposed to have at our disposal. And we wish to apply that one to what we currently have in front of us. So we do see similar elements, of course. We can see that the top part, well, not top part, well, kind of, right? Because we know we're probably going to have to move this over to the other side by dividing it from both sides. But make note that we have this one here which matches that argument, so that's already good. And then this argument here matches that argument, so that is also good. And then we have a 1 motif there which matches this 1 motif. So we just need to take this entire thing on the right hand side and then quote unquote move it to the left hand side. And we can move it by dividing both sides by the entirety of it. So let us open up with that move. It is unusual because the terms have been switched, so to speak. We can see in the bottom here it's 1 minus that thing right there. So with this one, well, let's just let's multiply both. Let me think. Yeah, that's fine. We can factor out a negative from those two terms. Yeah, let's factor out negative out because I want this one to look more like that one. Because I don't like this little switcheroo where the one is on the back, quote unquote, and then this one's in the front, whereas the one is in the front, but then the product is in the right hand side. So I'm going to slap on the old parentheses and I'm going to factor out negative from this entire thing right there. So I'm just going to copy paste it just to save a little bit of trouble. So copy pasting that, again we're going to be factoring the negative, so once we factor the negative we can alternate the signs. A little bit of laziness right here, right? So take this one, and then once we factor the negative, this negative one will become positive one, and then this positive tangent product will become a negative tangent product once we factor out the negative one from those two terms. So that's going to be the strat. I just need to clean this up just a little bit, so I could put these between the parentheticals. Okay. So there it is, but be careful. At this stage we factored out the negative one, so be sure to please put the negative one out in the front. Otherwise things get really terrible. So negative one has been factored out. So again, if we take this negative one and we distribute it back, we're going to get back to the minus one. And we distribute this one to the product. The signs here will cancel to become positive in the front. So now this one looks more like that one. And we're going to divide this parenthetical thing from both sides. So let us execute that. So it's going to be this entire thing divided by that entire thing. So again, to expedite the process, I'm just going to copy the left hand side. So that's the left hand side. And then we shall divide the entire left hand side by the right hand side, except for the negative 1. So this is what we're dividing from both sides. Or, you multiply by under 1. Copy pasting this thing we did not divide from both sides. Alright, so again, all we did was we took this entire thing and then we divided by that entire thing. So the negative 1 is going to be left over on the right hand side. And now this one perfectly matches that one. So just double check, right? So that's going to be red argument, red argument, red argument. And then we have the blue one, and the blue one. And let's double check the signages as well. We do have a plus on the top and then a minus on the bottom for the plus condensation. So we are good to go. Everything is as it should be. So thus we can finally do the condensation. So here we go. It's just going to be tangent of argument number 1 plus argument number 1 plus argument number 2. Seven plus the x plus 2 pi over 28. Close the parenthetical as you could see, negative 1. That was argument number 1, and then that was argument number 2. And since this is a 7, and then this is a 28, so the common denominator, the lowest common denominator is 28. So top and bottom times 4. So I'm going to take the 4, I'm going to distribute it to each of those two terms. And then 4 times 7 gives us 28. So same strategy as the previous problem. Since this is the coefficient for pi, and that is a coefficient for pi, we're just going to add the two parentheticals and put it in front of pi. So 4x plus 2 plus this one. 4x plus, I'm sorry, 2 times 4 is 8 plus that one. So all of that is in front of the pi. This is all over 28, but I'm just going to go ahead and simplify this right away. In the parenthetical, all over 28. That is the argument for tangent function. We're supposed to get a ratio of -1. But be careful, this is a tangent situation. So this negative here has neither of those are related. Neither of those are giving the ratio for the hypotenuse. So we can interpret this in two ways. It could be -1 opposite over +1 adjacent, or +1 opposite over -1 adjacent. And thus we sketch out the reference triangles. So let's do this one first. We have a negative opposite over +1 adjacent, so that is in quadrant 3. Where the magnitude of the opposite matches the magnitude of the adjacent. So it's a 45, 45, 90. Oh, not quadrant 3. This is both adjacent and opposite are negative, so whoops, not this one. So quadrant 4. So this is the one where it has a negative opposite and then positive adjacent. And that is from here all the way to there. So that angle is going to be pi over 4 short of full circle, so it's going to be 7 pi over 4. There we go. And then we have the other one where we have a +1 opposite, but a -1 adjacent for the ratio. So from here and there. So that's a positive opposite, and then we have a negative adjacent. So this is a standard 45, 45, 90 in the quadrant number 2. So that's going to be 3 pi over 4. We're just one short of half circle. So there it is. I think that's it for the possible scenarios. So quadrant 2 and then quadrant 4. But technically we can consolidate this, because to quote unquote get from this one to that one, all we need to do is just add half circle. So plus, if you just add 1 pi to this one, so check it out, if you just plus 1 pi, that's going to be 4 pi over 4. And then the 3 plus the 4 pi gives us the 7 pi that we desire. So we don't need to put 2 pi k, because if we do 2 pi k, that will take us from quadrant 2 back to quadrant 2. But we can simply travel to quadrant 4 to get to this triangle as well. So for every single half pi, for every single pi that we add, which is just half circle, we can go from quadrant number 2 to quadrant number 4. And if we add one more pi, it'll take us back to this one. So what I'm saying is we don't need to put 2 answers for the situation. We don't need to consider 2 separate scenarios. So we don't need to put plus 2 pi k. Because if we do that, then we're kind of isolating it from this answer. So we're going to have to report 7 pi over 4 plus 2 pi k. Where k is an integer. So this is one feels separate from that one. So which I guess isn't technically wrong. But in order to be succinct, we can capture those two in one whole answer. So rather than having 2 separate ideas as answers, we can instead just keep one of those. So we're going to keep the smaller of the 2 one. So rather than report 7 pi over 4, we're going to report 3 pi over 4. And because we're not doing full coterminal angles to get to the next one, we're just adding half of a full circle, which is plus pi. So basically what this means is, here's our reference angle, leads up to from here to there. And then again, for every half circle, for every pi that we add, if we just add 1 pi, it'll take us to the second answer. If we add 2 pi's, it'll take us back. 3 pi's will take us back to this answer. And I hope that's clear. So rather than reporting answer number 1 and answer number 2 with the plus 2 pi k's to each of them, we're just going to report one answer with plus pi k only. And that's the only one we're really dealing with in terms of zones of consideration. So we're going to copy paste the argument. What argument will lead us to this particular angle? So let's do that. So we'll take it. We're going to take the 5x plus 10 pi all over 28, and we will force that to be equal to the only scenario that we care about, which is 3 pi over 4, and all infinite answers, so plus pi k. K is an integer. Yeah. Alright. So again, only one scenario to really consider. I'm going to multiply both sides by 28 over pi to clear the fraction and the pi. So this one cancels with this one. That one cancels with that one. So leave us with just 5x plus 10. And of course, make sure to distribute this one to that one. So this one partially cancels with the 4, giving us 7. So 7 times 3 is 21. Then the pi's cancel. And then lastly, this one times this one. The pi's cancel, but the 28 does not. Okay. And then, of course, we got to solve for x, so minus 10 from both sides, and then divide by 5. So minus 10, minus 10, and then divide by 5. And then, again, the 10 canceled partially with this one, so we just need to divide 5 from the 28. I'll just do the old extension thing. The old extendo. Something feels wrong here. I hope I didn't mess up something. Oh, whoops. The color's changed. Okay. So, I think that answer is correct. Let me check real quick. My answer sheet, pre-written problems. Oh, according to my pre-written answers, it's 15 plus 28 k over 5. So, that's interesting. Well, let me double check something real quick. Alright. So this one should be the answer. I don't know what went wrong. Let's double check. So this one to this one is 3 pi over 4. Does that give us the desired -1 ratio? Yeah, it's going to be positive 1 over -1, which is indeed -1. This should be the proper setup. Let's make sure this part is correct, though, right? Let me think. To get those to match times 4. So this is going to be 4x plus 8. 4x plus 8, yes. Plus x plus 2, yep. And then those two sum up to be 5x, yes. And then positive 8 plus positive 2 is indeed positive 10. Yeah, that should be correct. That's interesting. Well, let's just settle this by punching in the old calculator just to make sure things are correct. But I think this answer should be good. But you know, let me double check. It's going to take a while though. Hold on. So I'm just inputting the first one. Tangent of x plus 2. And then that's pi. Pi over 7. Plus the second term, which is going to be tangent of x minus 2. Times pi over 28. That's going to be equal to tangent. I should just copy paste. X plus 2 pi. All over 7. And then times tangent of X minus 2 times pi all over 28. And then finally minus 1. Alright, let's see what this is equal to. So I'm just hitting enter on the calculator. Hopefully it's inputted correctly. Apparently I mismatched the parentheticals. Whoops. That's okay. It should be fine. Okay, that's very messy. Yikes. Well, calculator that I used gave off kind of a weird situation. Computation timed out. Wow. Okay. Well, let me try to fix the parentheticals. Alright, so that should be fine, and then let me check the other ones. Okay, computation timed out. Okay, something's really weird. Something is very bizarre with the situation, so let me change the form real quick. Or I might have to use a different calculator, honestly. You failed me for the last time, Wolfram. Okay. I've changed the form just a little bit. So let me, hopefully this works out. Oh, okay. We actually got the answers. But the computation's still timed out. That's really weird. Alright, well, let's take a short pause here. I'm actually going to check it on a more powerful web browser calculator. We're not sponsored by anything, of course, unfortunately. So let me type it in real quick. Alright, hold on. Give me a moment. And of course, VOD users, you can always skip this part. Please do skip this part. I'm just going to check something real quick. So, inputting these values yet again, how tiresome, right? So inputting the first one, tangent of x minus 2 times pi all over... Oh no, the parenthetical's messed up. Hold on. Yikes. Okay, that's better. Alright, there's that one, and then... It's so clumsy. I even inputted it incorrectly. Whoops. Oh no, I undid. Okay, oh. I undid my work. But luckily there's an undo function. And now I can copy paste very easily, thankfully. Ugh, hold on. Okay, wonderful. Now we get a bunch of intersections. Ooh, this is really gross. So one of the answers is 3. And okay, so I think my original answer was correct. Hold on, let me check something. Oh, okay, so something went wrong here. Alright, so... Oh, you can't even see anything. Okay. Alright, so going back to this situation, I think I messed up the work somewhere. So, according to the answer sheet of my pre-written problems, the answer is supposed to be x is equal to 15 plus 28k all over 5. And then basically I checked it on the graph. And then one of the answers is a clean 3. So I can't get a clean 3 from this, right? I don't think. Yeah, I don't think I can get a clean 3 from this one. So I think this one must be wrong. And this one must be the correct answer. So the question is, where did things go wrong? Right? This is supposed to be a 24 5 then. Which means I... Is this right then? No, this is 21. That should be correct. Huh. I wonder how I got a 5 up here. Let me think. Which means... Do I have to do the problem all over again? Let me think. Well, this is a plus between those two, so it should be this one plus this one. Yeah, this is a plus between those two, that's fine. And then it is a plus 4x plus 8, so that should be correct, and then this one should also be correct, yes. And those two add up to be this one, yes. 28 is on the bottom, yes. This is the pi type, yes. Copy paste, alright. That's interesting. 3 pi over 4 is the correct reference triangle, yep. I guess I'd better double check the algebra. Maybe I'll just have to restart this problem in the beginning, but let me double check this part. Proceeding more slowly, I guess. So multiply both sides by 28 over pi. So yes, those ones cancel out. Leaving us with 5x plus 10. Should be right. And then this one times that one. 28 partially cancels with 4, leaving us with 7. 7 times 3 should be 21. Yeah, that's right. And then we have the sum of those two. I mean, the product of those two is going to give us 28k. Okay, that looks right. Minus 10, minus 10. Yeah, that's an 11. Oh, what? It's always fun. Alright, let me check something real quick. Let me go back to my graphing. Yeah, 3 is supposed to be one of the answers. And then 19.8 is going to be another answer. Well, let me double check. 19.8. Which means 43 over 5. What does that equal to? That is an 8 point something. Let me double check. Oh wow, that's really bad. Hold on. So 3 should be one answer. And then 8 should be something. 8 should be another answer. Hold on, let me see. Well, this is not really helping, is it? If k is equal to 0, 0 works. It should work out. And then if k is equal to 1, we're going to get 43 over 5, which is 8.6. Which should be another answer, right? 8.6. But I'm just checking this on the calculator. Interesting. Okay, well maybe I just have to restart this problem. Unfortunately, it looks like it's gonna... Maybe this problem is not a good problem. But I feel like what I put was correct, though. Interesting. Okay, well, that's a little problematic. So let me double check to make sure that the input I put into the calculator is correct. Because again, I just need to verify the answers. But I felt like everything was done correctly. It's always fun debugging problems, right? Oh, wait. Wait a minute. Oh, no, no, no. Never mind. This should be correct. We're wondering where these ones intersect. So unfortunately, things are a little weird. Okay, well. Let me just do the problem again. So unfortunately, you can see it in the graphing action. That's okay. So let me just do this problem one more time. So again, I'm not sure if this answer is good, or even if this problem is good. But let me double check all the signages to make sure. The signage. Oh, okay. I see what has happened. Okay. I miscopied the problem. Yeah. Okay. So we're going to have to start this problem all over again. But for the most part, things are still the same thing. Okay. So, well, that's what happens, right? These things do happen. So everything, the setup was correct, and then given what was happening, everything was correct. It's just that the problem was miscopied. So here's the situation, and again, I missed the signages. Very unfortunate. It's the second argument that has a minus. The second argument is x minus 2. So I put x plus 2 for everything. So unfortunately, it's this one should be minus. Okay, so I want to say that the previous problem was correct for what it was, but it's supposed to be x minus 2. Oh, it's so inconsistent. Okay. So that's a minus 2, and then that's a minus 2 as well. Okay. Oh, wonderful. So always double check to make sure the arguments match up. So this argument matches with that argument. Now the x minus 2 matches that x minus 2. Okay, so we're going to start over again. VOD watchers, you are lucky. Kind of. Alright, well, here's the problem. We're starting over again. Pretend that the previous thing didn't happen. Let's just check a... Wait. I gotta delete this parenthetical real quick. Because that one was not originally there. So let us delete that. Alright, take two. Alright. So starting over again. Here is our problem. We've never seen this before. Wink, wink. Here's the problem, and let's see. It looks awfully like a tangent condensation situation, and boom, what do you know? I already have the formula written out. Right there. So what are we doing? We are trying to get this one into this particular form, and we make note that on the top portion here is a sum of two tangent functions. We do have a sum of two tangent functions, but we have a product minus 1, whereas this one has 1 minus the product. And anytime you have some sort of term switcheroo, especially with sign changes, all you need to do is factor out a negative. So what we're going to do is we're going to slap on the old parentheticals around those two, and then we're going to factor out negative from those two terms on the right hand side. So to expedite the process, I'm just going to simply copy paste that nonsense. And then we're going to execute the factoring of the negative 1 from these two terms right here. So what that involves is sign flippage. So this one is going to become a positive one once we factor out the negative 1. And then, of course, the product of the signs is going to become negative. So this is what we're going to end up with. So again, just typical sign flipping shenanigans. Once we factor out the negative from those two terms, we're going to get this rearrangement, which is what we want, because now it more closely resembles the condensation. So we can apply the property to this situation, but don't forget the -1 in the front. So all we did was we took this one right here, factored out the -1 from both terms, so this product becomes negative, and then this -1 becomes positive because we factored out the -1. So now this whole thing looks like the denominator for our condensation identity property. Okay. And what we're going to do is we're going to transform what we currently have to match this situation right there by dividing both sides by this entire parenthetical. So, some more copy pasting shenanigans. I'm going to copy paste that thing right here. This whole thing, we're going to divide it by this whole thing I'm selecting right now. Copy paste, my beloved. So again, dividing the entire parenthetical from both sides, we're going to get a -1 as a result right there. Alright. So, does this current thing perfectly match this one? Yes, it does. We have tangent red thing plus tangent blue thing. And both of those are over 1 minus the tangent product of red and blue. Tangent product of red and blue. So that's correct. So we can condensate this whole entire left-hand side. We can consolidate that into a very clean tangent of red argument plus blue argument. So here we go. There's going to be x plus 2 pi over 7 and then plus x minus 2, not plus 2, over 28. Copy pasting right hand side was just -1. Alright, so here we go finally. It's going to be thing number 1 plus thing number 2. The denominators are currently mismatched, so therefore we're just going to multiply top and bottom of that one times 4. So times 4 and then times 4. So distribute, we're going to get 4x plus 8. This one's going to be x minus 2. So we can consolidate the top portions now that the denominators are matched up. So we're going to get 5x plus 6, not plus 10, plus 6, all over 28. Of course, this is a quantity pi. That's what we end up with right there. And of course, this is a -1. We can interpret this in two ways. It can be a -1 opposite over +1 adjacent, or it could be a positive opposite over -1 adjacent. So if we sketch out the reference situations for those two, we're going to get situation number 1 where the opposite is negative but the adjacent is positive. So that's going to be quadrant 4. For the 45, 45, 90 scenario, negative opposite, +1 adjacent. Alright, and then that one's going to be from here to there. This is pi over 4 short of a full circle. In other words, that's going to be 7 pi over 4. So if you wish, you could have reported this as a negative situation. You could call it -pi over 4. It doesn't matter which one you choose, honestly. So I preferred positive, so I'm going to keep it at 7 pi over 4. And then the other scenario, this one right here, we have a positive. We have a positive opposite, but a negative adjacent, which means we can have this scenario in quadrant 2. So from here to there, that's 1 pi over 4 short of half circle, so that's going to be 3 pi over 4. So that's one less than right here. Yeah. And because of the weird dynamics, we can actually consolidate these two scenarios into one scenario. So rather than having to deal with two scenarios, we're just going to base it off of this one. So we're going to call 3 pi over 4 is the most basic positive reference angle situation. And instead of adding plus 2 pi k, because if you do plus 2 pi k, we're going to skip over and go back to here. But we also want to capture the dark purple situation. So rather than adding plus 2 pi k, we're just going to add plus 1 pi. If we just add 1 pi, it will take us from the triangle, the reference triangle in quadrant 2 to the reference triangle in quadrant 4. So again, we can encapsulate both of these scenarios, quadrant 4 and then quadrant 2 scenarios, in one clean answer by just adding 1 pi instead of adding 2 pi's, but still based off of k. K is an element of integers. So there we go. And we're going to force our argument to be equal to all their answers. So thus do we get 5x plus 6 times pi all over 28, and then that's going to be equal to desired angles, which is 3 pi over 4 plus pi k. Alright. And with standard manipulations, we're going to clear the fraction by multiplying both sides by 28, and then we want to clear the pi, so divide by pi to isolate the x eventually. So cancel, 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 cancel for the left-hand side. So we're going to be left with 5x plus 6 is equal to what? This one times that one. 28 partially cancels with the 4, so we get 7. 7 times 3 is 21. The pi's will cancel out. And then lastly, we have this one times that one. The pi's cancel, but the 28 does not. Leaving us with that one, and then we're going to isolate the x by subtracting the 6 from both sides. So divide by 6, I'm sorry, minus 6 is equal to 15. And then we'll divide all terms by 5. We will keep these two together. So divide by 5. Those two, the sum of those two, divide by 5. Okay, now this matches the answer key versus before. Again, the previous situation didn't happen, so that's the final answer. And k is, again, in the element of integers. K is an integer, is what this is saying, essentially. Alright. And now the problem, it's good. Good to go. So let us cross that out. And I think that's it for the algebraic portion of the condensation for the tangent functions. And now we're just going to do a bunch of mixed problems until I gotta go. Alright. But first, sip of tea. Let me get the right coloration for this one. Okay, perfect. Can't get enough of that scuff. So now we move on to second portion. So those first 4 problems, they were just a continuation from last time's stream, basically doing the condensation problems, but with algebra in them, with the variable x. But now we're just going to be dealing with a variety of problems, so just mixed problems from here on. So old faces coming back, of course, old style of problems. So we're starting off with this one. We're given a sine function. Statement number 1, and then statement number 2. So again, we're doing the mixed bag situation. And of course we have cosine, so cosine beta. So be familiar with what's happening right here. This is sine of the alphas. This is sine of alpha and tangent of alpha. So these two in tandem gives us clues about the angle alpha. And this one's going to give us beta information. And then we're told that the beta is an angle between negative pi and 0. And we are asked to evaluate cosine of pi minus beta. So this is a fairly standard problem, honestly. You see this quite a bit in trig situations after you learn your condensation identities. So here we go. This is just a standard cosine situation. It's going to be cosine expansion of those two arguments. Cosine, you keep the two cosines together, so it's going to be cosine of alpha times cosine of beta. This is not sine, so you don't keep the same sign. So this minus, following the algorithm, becomes positive, and then we do our two sine functions: sine alpha, sine beta. What does that equal to? Well, in order to determine that, we need to know where the alpha lies. This one gives us information on the alpha, so we do need to sketch out the triangle for the alpha situation. So let me color code this just a little bit. Let's call this one the purple situation. So what's alpha doing? Well, alpha, sine of alpha gives us a ratio of -1/2. So we could be in quadrant 3 or in quadrant 4, because those two quadrants are where we get the negative opposite situation. But coupled with statement number 2 about alpha, the tangent is going to give us a negative situation. So it can't be third quadrant, because if we consider third quadrant, this will be a negative adjacent as well. And if you do opposite over adjacent, both those negatives will cancel to give us positive ratio. This is not a positive ratio. So it can't be this one, which tells us that alpha is in quadrant 4 only. So there we go. And then all we have to do is just take the ratio from there. So the ratio for the quadrant 4 scenario is -1 opposite, √3 for the adjacent ratio, and then 2 for the hypotenuse for alpha. And then now we just need to do the same thing for the beta situation. So what's happening for the beta? Beta gives us a ratio of positive √2/2, which again, I like to rewrite this as 1/√2 because I'm more familiar with this one. The adjacent is positive, so we could be in quadrant 4, or we could be in quadrant 1 in order to get a positive 1 adjacent. But we are given a range, domain restriction for angle beta. It's from -pi to 0. That's kind of weird though. So this is -pi, and then this is to 0. So it must be in quadrant 4 as well. So again, because of this particular domain restrictions, it cannot be in quadrant 1. So we know it lies in quadrant 4. And let's get the ratio. It's 1 to -1 because it goes downwards down the y-axis, and then to positive √2. So that's for beta. So we have the beta location, and then we have the alpha location. We can get to answering this, evaluating this situation by referencing exactly what we sketched out. So cosine of alpha is going to be this one. It's going to be √3/2. You know what? I should follow the color for clarity, for visual clarity. So cosine of alpha is this one, √3/2. And then cosine of beta is reference to this one right here. Cosine is going to be the adjacent over hypotenuse, so √2/2. And then we have a plus between them. Plus what? Going back to the alpha situation, so now sine of alpha, which is going to be -1/2, times the sine of the beta, which is going to be negative, so in the parenthetical, -√2/2. So that's the setup from the reference triangle that we sketched out. So let's just get to evaluating the situation. So two negatives cancel out. So it's just going to be √6/4 plus positive root 2 over 4. So same denominator, so we just simply sum the top portions. So this should be the answer for the first one. And then we're good to go for this particular problem. There it is. Finish. Mixed question number 2. We have a sine function. We're taking the sine and applying it to 29 pi over 12. So we're starting off with a condensed situation. This is just a lonely sine function, but paying attention to the argument, the 12 one, that's not one of our favorite numbers. You know, our favorite numbers being like 2s, 4s, 6, or 3s, right? So we know there's some sort of gimmick to this problem, so we probably either apply half angle, but we know we didn't do half angle situation, so we only have the expansion. So we need to split this up. We need to split the 29 pi over 12 into a sum or a difference of angles, and then we expand it so that we can actually evaluate it without the aid of a calculator. Alright, so this is going to be expansion situation using sum or difference property. Alright. So the question is, what can we split the 29 into that works nicely with the 12? And by nicely, we should be able to simplify something. So a plus b has to give us 29. But a and b themselves need to have factors that are cancelable with something inside the 12. So considering that, what can we split the 29 into? We can do 27 plus 2. Yeah. And this is a good option because 27 is divisible by 3. And then this one is divisible by 2. And so is 12. So this is, in my opinion, an optimal situation to pick. But that's not the only combo we can pick. Let's see what else we could potentially pick for the situation. So we could pick 36, I think. Wait, let's 36 minus. No, 7. Minus 7 is bad, so we can't do this one. What else can we do? We can do 24 plus 5. No, that's not nice because 5 doesn't share any factors with the 12. So splitting 29 into 24 and 5 is not a good situation. We can do 21 and... Oh, we can do 21 and 8. That's also a workable situation. So you don't have to pick 27 plus 2. You could also choose to do 21 plus 8, which gives us 29. And then the 21 is partially cancelable with the 12, as is the 8 with the 12. So these are two possible scenarios, but honestly, just pick the first one you can find. So I'm going to stick with the 27 plus the 2. So if we split 29 pi into 27 plus 2 of pi, then we can simplify this. So 27 pi over 12, and then the 2 pi over 12. And we're doing this as a sum. You can somehow figure out a minus situation as well if you wish. But again, I'm just picking the first one that I came up with. You know, because we want to save time. This one simplifies into top and bottom and divide by 3, so that's 9 pi over 4. That's reducible. And then the second one, top and bottom divide by 2, is pi over 6. And we know this is reducible because 4 times 2 is 8, and this one exceeds 8. So we can subtract a full circle from this one. So minus 2 pi, which is minus 8 pi over 4. So this one, we can simplify it into simply pi over 4. You know, that's like the lowest positive answer we can get. So this is coterminal with that. But why work with bigger numbers when you can work with smaller numbers? So here we go. We now have this particular situation. And let's use our expansion. This is a sine expansion, so you keep the same sign. This is going to be the sine, cosine, cosine, sine scenario, if you like algorithms. Sine, cosine, cosine, sine. Sign keeps the same sign. Argument number 1 and then argument number 2. So argument number 1 is pi over 4. Following my version of the algorithm. I think most people do it this way. Some people flip these two. It's not my favorite strat, honestly. But as always, whatever works for you. So here we go. We have the similar situation, and now all we need to do is sketch out the reference triangles. But let me color code a few things just to keep things visually informative. Blue is argument number 1, and then red is argument number 2. This is a sign expansion. This is a sign expansion with a plus and a plus. Okay. And then for the blue situation, we have a classic pi over 4. That's just in quadrant 1. So that's going to be a 1 to 1 to root 2. And then for the red reference angle, again, quadrant number 1, this is going to be over 6. So that's the skinny angle. So that's a 1 to root 3 to 2 ratio. We have our two sketches. And now let's just get to evaluation. So sine of the blue one is 1 over root 2, which is root 2 over 2. Cosine of that one is root 3 over 2. Familiar combo. Cosine of that one is just root 2 over 2. And then sine of that one is 1 over 2. Cleanup step, we get root 6 plus root 2 all over common denominator of 4. And then we're done with this first problem. Evaluation. You don't need to show that much work if you don't need to. But there is the full entire work right there. And we are done. Moving on to second problem. Tangent situation. Just go ahead and evaluate as I'm writing it out. Or not evaluate, but just come up with a strategy. See if you recognize the scenario. So neither of those arguments have a variable. So this is just straight up evaluation. And indeed, it's just evaluation. So further inspection, we have a pi over 15, which is not a friendly angle, and we have a pi over 10, which is also not a friendly angle. So we know this is going to be some sort of condensation situation with our tangent function. And it simply is. Let's just get to that. So this is a minus on top for the tangent situation. So the condensation is going to work out in this particular fashion. So it's going to be tangent of, since this is a minus, then it will be a minus. This is argument number 1. And then that is argument number 2. So this one just perfectly matches the form of one of our algorithms for tangents for the condensation. And it will condensate into this one right there. You can double check it. Make sure you reference your properties to make sure everything lines up perfectly. So this is argument number 1. And then that is argument number 2. Minus on top, plus on bottom. So we keep the minus 1 on top. So getting to the evaluation, we do need to consolidate those two. This is going to be 15 and 10, the lowest common multiple being 30. So top and bottom times 2. Top and bottom times 3. Ooh, we have a negative angle. Interesting. Oh, that's not the best, is it? Interesting. Well, let me think about this. Hopefully I didn't mess up the problem, right? Okay, that's fine. So we're going to get the, what are we going to get? We're going to get negative pi over 30. That's very interesting. Maybe I miswrote this problem. So can we evaluate this as it is And not really, right? This is kind of a bad situation because 30 is not one of our classic 2s, 3s, 4s, or 6. This is a 30. We typically want one of those ones on the bottom kind of situation. So unfortunately, we do need to manipulate this one. So do we have to back expand it? Which is kind of funny, right? Because we start off with these ones right here. And then we consolidated it, but our consolidation leads to something that's just kind of gross. So maybe we just have to back expand this one into a nicer scenario. So let us consider that one. So the top portions are going to be a plus b, or a minus b is going to have to give us negative 1 over 30, right? So consider this. We need a and we need b to be nice numbers. And I think the nicest one off the top of my head is 5 and 4. Again, you can always find a different number, but for those two are the easiest off the top of my head. Because 5 shares a factor with 30, and then 4 shares a factor with 30 as well. Can we do better than that? Well, this one ends up being a nice 1 over 6. So this one is one of our favorite angles. But I think the second one isn't so nice. This is going to be a 2 over 15. Yeah, that's not super nice. So let's consider something farther up. So 5 over 4 was a nice first consideration, but it ain't the best. So 6 and 5. Okay, 6 and 5 is perfect because that one is going to simplify into 1. Oh, no, this is not a nice situation. I'm sorry. No. So this one ends up being nice because that's 1 over 6, but this one is not nice because that's going to be 1 over 5. Yeah. So let's pick something that's one space apart as well, but each of those numbers are nicely cancelable with the 30. So what else is there? We've tried 4 and we've tried 3. We've tried 4 and 5. Wait, we didn't try this one, but that one does not end up being nice because 4 over 30 is going to give us 2 over 15. So 4s are not nice. We can do 5 minus 6. That's the one we just looked at. 6 minus 7. No, 7 is not nice. And then 7 and 8. Nope. 8 and 9. No. And then 9 minus 10. Is that a nice situation? Maybe this one. Let me see. Let me see real quick. So if we do 9 over 30, is that a nice situation? 3 over 10. No, that's not nice, unfortunately. Yeah, this is not a nice situation, but the 10 over 3 is nice. So let's just keep going. So we're just brainstorming what a minus b could be as a combination that leads us to this one. And a and b themselves, once we split them, need to be divisible partly by 30 in part. So not a nice situation. So I'm just going to list a bunch of numbers, and hopefully we're going to hit something very nice, right? 20 and 21. I'm just shotgunning ideas at this point. This is going to give us 7 over 10. No, 7 over 10. We need to clear a 5. The whole problem is the 5 on the bottom. So 24 and 25 might do it. Yes? 24. Let me think about this. No, because we still end up with a 5 on the bottom, unfortunately. Maybe this is a poorly written problem. It could be a poorly written problem. Let me think. Because the whole problem is we end up with a 5 on the bottom. Because if we do this one divided by 30, we're going to get 8 over 10, which is going to be 4 over 5, which is not a nice situation. Okay. So I'm going to check something real quick. Consulting the good old calculator. Let me think. So I hope this problem isn't just screwed up. So 2 pi minus 3 pi is pi over 30, negative pi over 30. Okay, so I'm just inputting this to the calculator. If it gets a nice situation, then it should be nice. Okay. Well, that was not very useful. I'm punching on the calculator. So I think maybe I messed up writing this problem, but is there a way we can just do this without, with the current tools at our disposal, right? Let me consider this real quick. I think we just need to use our properties twice, which is kind of unfortunate, which is not what I wanted to do. Because, you know, yeah, we're just going to have to do two properties maybe. Okay. So the situation still stands. Again, we make note, so I think we should probably start over again for the VOD users. So here we are. We're starting off with this particular problem. It's going to be, we recognize that it does fit our algorithm. So this one, we can consolidate it into that one. And then those two, we can combine those two by doing common denominator, top and bottom times 2. Top and bottom times 3. And then the 2 pi minus the 3 pi gives us negative pi, so consolidate into that one. This is not a very nice situation. So now we go back to expansion. So the question is, what a and b will lead us to a -1 for the in front of the pi? So we're considering what could be a and what could be b. Okay. So I think we're going to pick this situation first. Or maybe this, let's pick this situation. I guess it doesn't matter. Let's pick this situation. I think these are the nicest numbers to work with right off the top of my head. So that's what we're going to go with. A is 5 and B is -6. So we're going to do a re-expansion, which is kind of weird. Because we condensed the problem, and then now we're expanding the problem. But that's okay. Let's just see where that leads. So we have a 5 minus a 6. So 5 pi minus 6 pi. That's going to be the expansion proposed, and each of those fractions is over 30. Again, not my favorite situation because this one simplifies into pi over 6. Oh, that's good. This is what we want. Pi over 6. It's the second one that we don't want, because that one is a pi over 5. So that is unfortunate. Because once we do the expansion, this one, we can take care of that. That's no problem. Tangent of pi over 6, this is a familiar friend. This one is not so nice. Pi over 5. So let's consider this one. Can we change this one into a nice scenario once we end up with pi over 5, right? So now we go to another breakdown, a minus b part 2. And we want to equal to 1 for the coefficient for pi. So can we do that with a 5 on the bottom? Not that I can think of. Not a good one, right? We can do 5 and... No, 5 and 1 ain't going to work. No, 5 and 4 ain't going to work. So nothing's... Yeah, I think this is just a bad situation. So unfortunately, I think maybe we're just going to abandon this problem. But before we abandon this problem fully, let me jump to this online calculator real quick. Just to see something. Because I want to absolutely double check to make sure that this problem isn't a lost cause. What is that? Well, unfortunately, this online calculator gives approximate answers. It doesn't give us a nice exact answer. Well, again, let me check with a different calculator. I think it's just a bad answer. A poorly written problem. So we're just going to skip this problem. That's fine. Alright, so unfortunately, I don't think this answer is good. I don't think this problem, as it's written, is going to be good. So unfortunately, we're just gonna abandon it for now. So this problem was a flub. Let me think if plus would have worked. Let me think about this for a moment. If this had been plus and this had been minus, will that have worked out? And maybe we'll end up doing this problem instead, right? So let me do 2 pi plus 3 pi, and I think this would have ended up being a nice situation. Again, just double checking this one real quick. So we're going to get 5 pi over 30, which is pi over 6. Yeah, I think it's supposed to be a plus on top. Okay, so I'm going to make the executive decision at this point. And I'm just going to change the problem. Or, you know what? Let me think about this. So before it was written as a plus or a minus, right? So if we think about this, if we factor out a 1, no, it'll still be a minus. Okay, so I'm just going to change the problem, and we're going to do a new problem altogether. And we'll pretend that the previous few minutes did not even exist. So this is going to be a plus, and this is going to be a minus. So here we go. All right, so this is the actual problem. This one is a plus, and then this one is a minus, and then now we should be able to do this particular problem. So we make note that this one perfectly matches the condensation property. Again, the condensation property being tangent of thing number 1 plus thing number 2. If we expand this out, it's going to give us tangent of alpha plus, keeping the same sign, tangent of beta, all over 1 minus tangent of alpha times tangent of beta. So this one perfectly matches this one, and thus we should be able to condensate from here back to right there. Keeping note, this is argument number 1, and then this is argument number 2. These ones are indeed matched up, and then those two are indeed matched up. This is a plus on top, minus on bottom, minus on bottom. This order here matches this order, so yes, we can perfectly condensate this one with no particular manipulations. So let us get to it. Consolidating into tangent of argument number 1 and plus argument number 2. So all of that consolidates into this nice thing right there, which we haven't seen before. So common denominator is going to be 30. So top and bottom times 2 gives us 2 pi. And then top and bottom times 3 gives us 3 pi. And then this is actually a very nice situation because 2 pi plus 3 pi gives us 5 pi. And that is perfectly simplifiable. Divide by 5 gives us a very clean pi over 6. What do you know? This is very easy. It's just standard quadrant 1 scenario. That's just pi over 6, so it's going to be the slim angle, opening up to positive 1 to an adjacent of root 3 to positive 2 ratio for the hypotenuse. What's tangent? It's opposite over adjacent, so root 3 over 3. And then we're done with this particular problem. And good to go. And I think we're going to end it for right now, because I do got to do something. And then we'll be back to do more review, and we're going to cover one more property for the trig functions before we move on to more trig functions. Unfortunately, the trig function is the trig situation is pretty expansive. There are like numerous properties to go over. So I think next time we're going to cover, what are we going to cover? It's going to be the sum to product or difference to product rules for the sines and cosines. So look forward to that, and then we're going to do some review problems. So I think we're going to open up with review problems first, and then we're going to do some product introduction, and we'll practice those problems out. And then eventually, some other stream, we're going to be doing graphing of the trig functions. That's going to be mildly annoying. We haven't even touched the reciprocal trig functions yet, like the secant or the cosecant or the cotangents yet. And we've yet to touch the inverses for the trig functions. Those ones aren't too bad because technically we've already kind of worked with them. Technically, right? So look forward to that. And I think that's going to be it for now. I'll see y'all another time. You have a good one, a good day, good evening, a good afternoon. That'll be it. See you next time.